This is question 10 from the SACE Stage 2 Physics course companion from Subtopic 3.1, the wave behavior of light. Here we have a laser with a wavelength of 532 nanometers in a double slit experiment, and the separation between the slits is 0.25 millimeters, and the slits are placed 1.8 meters from the screen and a pattern observed. Here we need to calculate the angular position of the first maximum. First maximum is going to correspond to m equals 1 when we're using the relationship m lambda equals d sine theta. Therefore, sine theta will be m lambda on d, and theta will just be the inverse sine of m lambda on d. Now it's just a matter of substituting in the values that we've got. So here the inverse sine of m was 1, lambda was 532 nanometers, nano of course being 10 to the minus 9, and d 0.25 millimeters, so I need to put the 10 to the minus 3, and putting that to our calculator gives us 0.12 degrees. Now I need to work out the third minimum. This is a little bit tricky. So here, since we're calculating the minimum, we're not using m lambda equals d sine theta, we're using m plus half lambda equals d sine theta, because destructive interference will occur when the path difference is half a wavelength out. And here it's a little bit tricky because the third minimum corresponds to m equals 2, not m equals 3, because the first minimum occurs when it's half a wavelength out, so here that'll be m equals 0. The second minimum occurs when m equals 1, third minimum occurs when m equals 2. Then it's just pretty much the same as what we did before, so we'll have sine theta equals m plus half lambda on d, therefore theta will be the inverse sine of m plus half lambda on d, and if we substitute the values in, it's easy enough. The inverse sine of 2.5 times 532 nanometers on 0.25 times 10 to the minus 3 meters, and if we substitute that into our calculator, we get 0.30 degrees. Finally, we need to calculate the distance between adjacent maxima. So here we're using the relationship delta y is lambda L on d. And all we're doing is substituting in the values. So here 532 times 10 to the minus 9 for the wavelength. Slit to screen distance from the question was 1.8 meters, and little d, as we have before, 0.25 millimeters. And if we substitute that into our calculator, we get 3.83 times 10 to the power of minus 3 meters. That's fine. I think it looks a little bit nicer if we write that as 3.83 millimeters. But that's it. It's fairly easy, just a straight substitution. This second one was a bit tricky, but the rest of it should be okay. These are all fairly reasonable questions that you can be expected to see in a test or something like that. It's a fairly simple rearrangement and substitution. Yeah, it's not much to it. And that's it.